Hello everyone, moving on with the compounds of aluminium. In this video I would tell you about two more important compounds of aluminium, that is aluminium chloride and alums. Okay, so first of all we would see aluminium chloride. Okay, now aluminium chloride generally exists in hydrous form. Okay, so in hydrous form, the formula for aluminium chloride is AiCl3.6H2O. Okay, now it is primarily colorless crystalline solid. Okay, it is colorless and it is a crystalline solid. Okay, in anhydrous form, it is white. In anhydrous form, AiCl3 is white in color. Okay, now we can prepare this. We can prepare AiCl3 preparation. Okay, we can prepare aluminium chloride. Okay, by dissolving aluminium or aluminium oxide or alumina or aluminium hydroxide in HCl. Okay, so by dissolving aluminium, alumina or aluminium hydroxide in HCl. Okay, so what will happen is that aluminium in all these cases would react with the chloride present, okay, and will form AiCl3, and AiCl3 will get formed, okay, and rest other water or hydrogen will be generated. Okay, so the reactions are as follows. Okay, now the first reaction is aluminium will react with HCl to give AiCl3 plus hydrogen. Okay, now in this case you can see when aluminium will react with Cl to form AiCl3, then the only thing left would be hydrogen, so it would be liberated over here. Now balancing this, we would get 2 over here and 3 over here. Okay, now the next reaction is when we dissolve Al2O3 in HCl. Okay, now when we do this again, aluminium will form AiCl3 plus, in this case you will see that H2O would be formed. Okay, again aluminium reacted with Cl and oxygen reacted with hydrogen to form H2O, and here we get AiCl3. Balancing this again, we would get 6 over here and 2 over here and 3 over here. Okay, the next reaction is when we dissolve AiOH whole thrice in HCl. Okay, again in this case AiCl3 plus what would be formed? H2O would be formed. Going by the same rule, aluminium will react with Cl to form AiCl3, and here OH and H would give H2O. Okay, balancing this again, we would get 3 over here and nothing else, and 3 over here. Yeah. Okay, so this was the way to prepare aluminium. Now another important way to prepare aluminium is, okay, when what we do, we heat a mixture of alumina and carbon and pass chlorine over it. Okay, so another important method is heating a mixture of Al2O3 and coke. Coke in this case is again carbon. Okay, and passing Cl2 over it. Okay, so the reaction for this case is Ai2O3 Okay, when Ai2O3 and carbon mixture is heated and when chlorine is passed through it, okay, so what happens? AiCi3 is formed. Okay, this would be anhydrous. Why it would be anhydrous? Because you are heating it. So heating would remove all the water molecules, and now what would be left? Aluminium reacted with chlorine to form AiCi3. So what is left? Carbon is left and oxygen is left. Okay. Now this would give you carbon monoxide in this case. Okay. Carbon monoxide is liberated over here. Okay. Now this is another method for preparing aluminium chloride anhydrous. Now the properties. Okay. The properties of AiCi3. Okay. Now first of all, action of heat. First of all, you would see action of heat. What happens when we heat AiCi3.6H2O? So when we heat AiCi3.6H2O, we get Ai2O3, HCl and water. Okay. So when we heat AiCi3.6H2O, okay, we get Ai2O3 plus HCl plus water. Okay, this is again, this would be strongly heated. Okay, so when we heat AiCi3.6H2O, we get Ai2O3, HCl and water. Okay, balancing this, we get 6 over here and 2 over here. Yeah. Okay, now this action of heat is similar in several other chloride compounds. Okay, the example of other similar reactions are like when you heat zinc chloride, ZnCl2.6H2O, or you heat PeCl2.6H2O, or you heat, suppose, MgCl2.6H2O, or you heat FeCl3.6H2O. In all these cases, when you heat, then the compounds like M2O3, like for Fe it would be Fe2O3, or MO for ZnO, or BeO, or MgO. These would be formed. Okay, similar to this case. Similarly, as Ai2O3 is formed, which belongs to this category, similarly Fe2O3 would be formed, or for a divariant metal, Mg, Be or Zn, these would be formed when you strongly heat them. Okay, on strong heating. Okay, so when you heat these compounds strongly, the chlorides, okay, when you heat these chlorides strongly, then you get respective oxides, metals. Okay, water is removed, but the important point is you get oxides. Okay, now the next property is, okay, the next property is property number 2. Yeah, next property is action of moisture on anhydrous Cl3. Okay, action of moisture on anhydrous AiCl3. So what happens when we put water in AiCl3? Okay, so when we add water in AiCl3, we get AiCl3 plus water, we get aluminium hydroxide. Okay, we get aluminium hydroxide and white fumes of HCl. Okay, balancing this reaction. Yeah. Okay, now this HCl will give white fumes. Okay, white fumes would be formed. Okay, so you can easily check this reaction that when you take anhydrous, this is anhydrous over here. So when you take anhydrous AiCl3 and when you put water in it, you would get white fumes of HCl and AiOH whole thrice would be formed. Okay, now the next property would be property number 3, action of ammonia, NH3. Now when AiCl3 reacts with ammonia, okay, it forms, some of you might have guessed, AiCl3.NH3. So what actually is happening here? The exact funda that is happening here is the structure of AiCl3 is this. Okay, now when you put ammonia in it, so ammonia has 2 electrons and number of electrons around AiCl3 is how much? I told you initially also. Number of electrons around AiCl3 is 1 over here, 1 over here, 1 over here, and for aluminium, so you can count there are total 6 electrons around aluminium. So aluminium is electron deficient, 6 electrons, so electron deficient. Okay, now so what happens is that ammonia, so in this case ammonia will give it electron to aluminium and a complex and form a complex. Okay, so ammonia in this case gives it electrons and it forms a complex. Okay, now this complex will be formed and it would give AiCl3.NH3. Okay, this is a complex that would be formed when aluminium would react with ammonia. Okay, now the next property is action of NaOH solution. This is property number 4, action of NaOH solution. Okay, now this is an important property and you need to remember this. This is important. Okay, now what happens when we put AiCl3 in NaOH? Okay, now when we add, okay, when we add aqueous, when we add NaOH solution in aqueous AiCl3, okay, a gelatinous precipitate, of AiOH whole thrice is formed. Okay, this precipitate formed is somewhat white in color. Okay, now this precipitate dissolves in excess NaOH. Okay, this precipitate dissolves in excess NaOH. Now this is an important point. Okay, now how does this property helps? Now this property helps. Okay, this property helps in distinguishing. This property helps in distinguishing aluminium salt from salts of magnesium, calcium, strontium and barium. Okay, now because these salts, the salts of the following compounds, now the salts of these compounds, these do not dissolve. These salts, although these salts form white hydroxide precipitate, these salts forms white hydroxide precipitate like ammonia, like aluminium precipitate, but do not dissolve in excess NaOH. Basically, although a white hydroxide precipitate is formed, but this precipitate does not dissolve. Okay, this precipitate does not dissolve in excess NaOH. However, the precipitate formed by aluminium dissolves. Okay, so the reaction for this case is AiCi3 plus NaOH gives AiOH whole thrice. This is the hydroxide precipitate, white gelatinous, plus NaCl. Balancing this 3 and it's there. Okay, now AiOH whole thrice. Since now, why does it aluminium hydroxide, the product form? Why does the product form over here dissolves in excess NaOH? Because this is amphoteric. So dissolves in excess NaOH. However, the hydroxides of these elements are not amphoteric. Okay, therefore they do not dissolve in excess NaOH. Okay, so this, when reacted with NaOH, it would form sodium aluminate. Okay, from sodium aluminate plus water. Balancing it would get done. Okay, now this was one of the again important properties. Now the fifth property is action of NH4OH solution. Okay, so what happens when we add NH4OH solution to a solution of AiCl3? Okay, so again this is very important, and you should remember it. Now when we add NH4OH solution in AiCl3, again a white precipitate of aluminium hydroxide is formed, but in this time it does not dissolve in excess of NH4OH. Okay, so when we add NH4OH solution in AiCi3 solution. Okay, in this case, white precipitate of AiCi3, white precipitate of AiOH whole thrice is formed, which does not dissolve in excess of NH4OH. Okay, so the point to remember here is does not dissolve in excess of NH4OH. Okay, now this property helps in distinguishing aluminium salt from zinc salt. Okay, this property helps in distinguishing aluminium salt from zinc salt. Why? Because zinc salt also forms white precipitate. Okay, but the precipitate dissolves in excess NH4OH. The precipitate difference here is the precipitate dissolves in excess NH4OH. Okay, so this is the distinction, that the precipitate formed by zinc dissolves in excess NH4OH. Okay, now the reaction for this is AiCi3 when reacted with NH4OH, it gives AiOH whole thrice, this is the precipitate, plus NH4Cl. Okay, so you can easily see that what has happened, aluminium reacted with OH and NH4 reacted with Cl to form NH4Cl, and here AiOH whole thrice formed. This is white gelatinous. Okay, now this does not dissolve in excess NH4OH. Okay, so AiOH whole thrice does not dissolve in excess NH4OH. Okay, therefore we can separate this from zinc, the salts of zinc. Okay, zinc hydroxide ZnOH whole twice dissolves in excess NH4OH. Okay, so this is the distinction basically. Okay, now the next property is property number 6. The next property is action hydrolysis with water. Okay, hydrolysis with water. Okay, so what happens when AiCi3 is dissolved in water? Okay, so when AiCi3 is dissolved in water, okay, in this case it hydrolyzes rapidly, okay, to form again aluminium hydroxide and white fume, and again HCl would be formed. Okay, so what happens is that we won't get HCl in gaseous form, we would get HCl in liquid form. Okay, so when AiCi3 is dissolved in water, okay, it gets hydrolyzed rapidly to form AiOH whole thrice and HCl. The solution, the solution formed after the reaction is acidic in nature because AiOH whole thrice is a weak base. Okay, the base formed is weak, while HCl is a strong acid. Okay, now since HCl is a strong acid, while AiOH whole thrice is weak, therefore the solution is basically acidic in nature. Okay, so this is the important point which you need to remember in this case. Okay, now the next compound which we are gonna see is alums. Okay, so we will study a bit about alums. The topic is now alums. Okay, now the formula for alums, you must have heard quite well that potash alum. You must have heard of potash alum. Okay, so the general formula for alum is M2SO4 dot M prime 2SO4 whole 3, okay, dot 24H2O. Okay, this or M prime SO4 whole 2 dot 12H2O. Okay, this is the formula for alums. Okay, now the important point to remember in this case is that alums are basically, you must have seen also potash alum, okay, in your household. It is very easily available also. Now some of the common alums are potash alum. Some of the common alums are one, potash alum. Formula for potash alum is K2SO4 dot Ai2SO4 3 dot 24H2O. Another common alum is chrome alum. Okay, the formula for chrome alum is K2SO4 dot Cr2SO4 3 dot 24H2O. Okay, another alum is ferric alum. The formula for this is K2SO4 dot Fe2SO4 whole 3 dot 24H2O. Okay, another alum which you may encounter is, in fact you have encountered, is ammonium alum. Okay, now NH4, okay, whole twice SO4 dot Al2SO4 whole 3 dot 24H2O. Okay, now by seeing these formulas of alum, okay, when you look at these formula of alum, you find one thing in common. All these elements present, all these ions present over here are what? They are +1 ions. Okay, while all these ions over here are +3 ions. Okay, all these are +3 ions, and 24H2O is common. Okay, and these ions react in, these ions are in present, like, see, there is one metal with +1 oxidation state, one metal with +3 oxidation state, and two SO4 2 minus ions. Okay, so the important feature of alums is, okay, okay, we would write the important feature of alums is, okay, features atoms are, okay, we would say feature number A, M, okay, is any univariant that is +1 with which can donate 1 electron, univariant positive cation, okay. The next feature, M dash is a tri-positive, sorry, M dash is a trivariant, positive cation. Now why I got any over here? The reason for writing any is it is found that atoms of almost every unipositive element can be found in an atom, but M dash, okay, the trivariant elements are very few, and some of them are aluminium 3+, okay, these, or vanadium 3+, or chromium 3+, okay, basically P3+, the transition metal elements, okay, cobalt 3+, and so on, okay. These are the trivariant positive cations, okay. Now the next feature is M plus, M3+, and SO4 2- ions, okay, are present in the ratio 1:1:2, okay. So one SO4 ion reacts with one M plus ion, one SO4 ion reacts with one M3+ ion, okay. So the ratio is 1:1:2, okay. So this is basically these three are the only important thing which you need to remember about atoms, okay. With this we are over with the compounds of aluminium. Next I would start with the group 14 elements, the carbon family, okay.